Hi guys, and welcome back. I hope you are keeping well and safe wherever you are. We're going to look at type 3 equation at this point, and I will solve it also with just an extension or maybe a restriction. So here you are solving, okay, we're still on general solutions. You are solving sine 2x minus 10 degrees is equal to cosine of, okay, x plus 15. Now, things are quite different here. In the previous examples, you had either sine equals to a ratio 1 over 2 or something, or cos or tan is equal to 1 over 2, or cos equals to 9. Now here, in the second one, rather, you had now sine equals to sine of some angle, okay? Then you did arcsine. So in both first and second type, we will take arcsine. But here, it does not really work out if we want to take arcsine, because arcsine does not remove this cosine. So I'm going to use that little trick of reduction formulae. I hope you know it. Okay, remember, if I take this whole thing here as my theta, then you can recall that sine 90 minus theta is cos of theta. Okay, now where does this thing come from? Where does this type of an equation come from? And why should I bother? Okay, I want to quickly start off my talk there so that as we go together, you see why we get this kind of equations. So guys, here I am. I have plotted my two graphs. The one on the left in that equation was sine 2x minus 10. So it will be the red graph here, okay? The one on the right was cos x plus 15, which will be the blue one. So what we are actually doing in that equation, we want to find these points. You see on the graph, it's easy. I can find the points. There they are, okay? There they are. Okay, and I'm going to be solving for the between the interval 0 and 360 degrees. So you can see between 0 and 360, there are about 1, 2, 3, 4 points of intersections. So there are 4 x values at which the two graphs intersect, in essence. So when we get equations of type 3, we are actually solving for points where the sine is equal to the cosine. As a matter of fact, what I'm doing just here, I am actually giving you guys a nice trick to get over these things. If you struggle, then just plot the graphs. Yeah, that's it. You could have just plotted the graphs, okay, to find the general solutions. So as I said here, I'm going to put up a restriction. And from my graph, I said the restriction is going to be between 0 and 360. So we know now that actually we are just looking for 4 nice solutions. Okay, I wish we actually wrote those solutions down. So let's go and write them down so that we can verify our answers. So the first solution that we are looking for is 28.3. Here it is. The second that we're looking for is 115 degrees. The second is 148.3 degrees, and the last solution is 268.3 degrees. So let us see the power of trig equations or of solving general solutions. Okay, so I'm going to start off by using this little trick, as I said, of reduction formula. So I'm going to rewrite cosine in terms of sine, and I'm going to have here sine 90 minus. Now, very careful, guys. Check how I'm going to write this here. Okay, I'm putting up some brackets so that I do not neglect the fact that actually I'm going to have to subtract 15 degrees from 90. Okay, that is very critical, because if you not put up and you add up adding 90 and 15, you are not going to get any of those 4 points that we are looking for. So if I solve this here, I'm going to get a 75, because 90 minus 15 is 75 minus x. And remember, this whole thing is equal to sine 2x minus 10. So there we are. We've got this two functions. Now, in terms of sign, I promise you, if you plotted this again, you are going to get those same points. Remember, what are the points that we are looking for? So maybe let me just write them. We know from the graph that we want the following. We want the points 28.3, okay, and we want 115, okay. We also want 148.3 degrees, okay, and finally 268.3 degrees. The other points are out of the interval, okay. So let's see, as we solve, can we get all those four values? Okay, so if I take arcsine both sides, I'm going to have 2x minus 10 is equal to 75 degrees minus x. Now, guys, this is my reference angle. A reference angle or angle of reference. I hope you know this. This is one critical step. Okay, hence I am emphasizing a lot. Now, therefore, 2x minus 10 degrees is equal to, you know, we always start with the reference angle because that's where the ratio will be positive. So remember my k times 360, and it is important to mention that k is an integer. All right, now I gotta clean up and group some like terms. I get a 3x is equal to 75 plus 10. I think that's an 85. So let me just go ahead and write an 85 here plus k dot 360. Now, I'm not looking for 3x. I am looking for x. So I'm going to divide by 3 throughout, okay? And so x is, so 85 divided by 3, surprise, surprise, I'm going to get 28.3 degrees plus k dot. Now I'm going to have a 120 there, and k is an integer. Guess what? We have found our first solution. Of course, we got to do some process here. Remember, we have a restriction. Restriction, we must work between 0 and 360. So this is how we're going to start. Remember, k is an integer. Now think with me. 28 is way less than 120. So if I try -1, -2, and all that, I'm going to get a solution out of the interval already. So I'm not going to bother. I'm going to start with k equals to 0. So if k equals to 0, then guess what? This goes out, and the first solution is 28.3. We know it is there. We are fine. If k equals to 1, I get a 120 there, so I have to add 28 to 120. Okay, actually it's 28.3. Okay, so if I add that, guess what? I get 148.3 degrees. I don't know why I keep on writing this degree thing before my decimal there. May you excuse me, please don't inherit that habit. Okay, so there we are. Okay, I am continuing. Now I want k equals to 2. Okay, if k equals to 2, then what do I have? Think about this. If I put 2 there, I'm going to have 240, and I'm going to add 28.3. Guess what? That takes me to 268.3. I should actually say this is x, this is x, this is x. And guess what? These are the values that we want. Now, guys, if you think about it, if you put k equals to 3, folks, I'm telling you, you are late, because 3 times 120 is 360, and that will take us out of the interval. So from k equals to 3 onwards, there is no solution within that interval. So we're going to stop right there and there. All right. Now, remember, we are not done. We must look for another solution in the quadrant wherein sign is positive. So this all here, all this trouble was the first quadrant actually, where sign is positive. Another quadrant where sign is positive is the second quadrant, okay? And what is happening in the second quadrant? Well, we say it's 180 minus theta. So I'm gonna go ahead. Remember, my reference angle is 75 minus x. Okay, not 28.3. Okay, very, very important, guys. Please don't fall for that trap of using one of the solutions as your reference angle, okay? My reference angle remains the one that I have circled here. Maybe I should circle it in red so that you see where this is going. So I'm gonna sort this out now. 180 minus, again, check this, 75 minus x, minus my reference angle, in other words, plus k dot 360. That's where my second solution is, or that's what the second procedure that I've got to do to get my solution. So 180 minus 75, you should get something like 105, okay? So I'm gonna get 105 degrees here. Plus x, notice plus x, and then 2x minus 10 degrees. Now again, I group the like terms. So if I tidy up, I'm gonna get x equals to 1, oh, I forgot here, k dot 360, and k is an integer, right? 115 plus k dot 360 degrees, and I mentioned that k is an integer. Very, very important. Now again, I look for all my solutions because they said within this interval. Again, I go the same way. If k is 0, then what is x? X is 115. Guess what? There it is. Guys, I'm basically done right now, because if I want to put k equals to 1, then guess what? I am out of the range. So there's no solution. I'm out there because I'm going to do 360 plus 115. But that's a very big number, right? Out of the range. If I do k equals to minus 1, again, there is no solution because it is still going to be a negative number, and my interval does not consist of negative values. So therefore, I write my solution nicely in the interval. The solution in the interval x should be 28.3 degrees, 115 degrees, 148.3 degrees, 268.3 degrees. Is that it? Yes, that's it. This corresponds to exactly what we saw on those two graphs. So that's just the long and the short of it regarding type 2. I hope this has been very helpful and you guys understand it. So why don't you go ahead and see if you can try this on your own. So I'm going to give you this. Okay, so find the general solution for this one. So I'm going to give you a cosine one, okay, so that you can test yourself and see if you can get it here. So, and then let me just make it a little bit tricky and say minus sine. Just want to see if you guys can get to do the thinking that is needed here. So I'm going to make that 20 degrees. So go ahead and try this one. And let me be specific for x between minus 90 degrees to 270 degrees. I'm going to give you a very weird interval. Go ahead, guys, try this and see if you can win. I wish you all the best. And remember, you can always subscribe to this channel so that as more videos come up, they can catch you on time. Lastly, the WhatsApp group for the grade 11s is very active. Guys, they're putting questions and the friends answer. The nice thing about this, as I said, is a collaboration of students from different schools across the different provinces we've got here in South Africa. So you may want to, again, send us a message. We add you to the WhatsApp group, or we will give you our number for that WhatsApp group. It is down here, 07324, not 24, sorry. Yeah, 073, oh, okay, I was right anyway, 24888806. So go ahead and send a message there. The admin for the group will add you up, and you will be connected with your fellow mates. Until then, I'll catch you later. We've got two more types, type 4 and type 5. Then we will be done with the general solutions and left with just one section of knowing how to figure out the values of x or theta, whatever angle is given, in which the identity does not hold. Cheers.